Hello. European agrivoltaic potential is measured in gigawatts. The European Commission reckons covering just 1% of the EU's utilised farmland could result in as much as 944 gigawatts of installed capacity. But a harmonised definition of what agrivoltaics actually entails is a work in progress. Good afternoon and welcome to this PV Magazine Roundtables Europe session on agrivoltaics. Over the next hour or so, we're going to delve into some key issues at one of the frontiers of European solar. Now, there is staggering PV potential to be found on European farmland, but there are also technical and regulatory challenges to overcome. In just a moment, we're going to hear from Huasun Energie on why the module maker believes it's got just the right kind of solution for agrivoltaics applications. And we'll also check in with the European Commission on what progress has been made on agrivoltaics guidance for member states. Regulation is, of course, an area where small changes can have a big impact, and we'll also be joined by a panel of leading agrivoltaics experts later in the programme to discuss what is going on in key European markets as 2024 draws to a close. And before closing this session, we'll hear from Huawei on how its inverter business is faring in the field of agrivoltaics. Now, first up, we are joined by Christian Combs, who is Director of Business Development for Europe at Huasun Energie. Hello, Christian. How are you today?
I'm good, thank you. How are you doing?
Very good. Yeah, really keen to start talking about agrivoltaics here. I believe you've got a presentation for us, so if you'd like to dive straight in and we can catch up shortly.
Absolutely. Let's go. So, do you guys see my slides?
Almost.
There they are.
Yeah.
I don't want to spend a lot of time in our company. We are in many webinars. I hope everybody knows us. For those few who don't, we are currently the #1 manufacturer of heterojunction solar modules, cells, wafers, and that's from us. I want to focus on agrivoltaics today. And I want to give a nice overview, I hope, about agrivoltaics, because many people have a little bit of a narrow vision into it. So agrivoltaics is not just one thing, it's many things. Some agrivoltaics happen because putting PV on the field even increase the yield. And I don't talk about energy, I talk about food, increase the performance of the land. This could be maybe fruits, this could be some other crops. Some other agrivoltaics happen because the people who run the lands want to have a second source of income, and even if it's maybe not the most profitable by itself, it helps diversify their own profit and their own business. And finally, some of the agrivoltaics happen because of legal regulations that block the access of very good land for photovoltaic unless it is combined with agriculture, so that we as, let's say, citizens don't lose the agricultural use of land just because it's very good for energy. And some photovoltaics really wants to have access maybe to a place nearby, a connection point for the grid or so. So looking at that, we find then, let me click, we find very different topologies for doing agrivoltaics. And I want to divide into, first is the, I'm going to call it long post agrivoltaics, where you basically shade a lot the crop. This is typically to improve the performance of the crops. You can find modules where not all the cells are put, so there's some transparency. Sometimes the transparency is achieved by not putting everything under a window garden with solar modules, but just putting maybe rows of panels. And sometimes you have even that in the form of trackers. All of that is possible. If you look at the other part of agrivoltaics, is what I would call low density or low shading agrivoltaics, where you have vertical installations maybe that let you work on the field basically unaffected, or you have some fixed tilt or trackers where you can have, for instance, animals grazing. I saw just on the weekend nearby here in Munich, some animals grazing next to some fixed tilt modules. And those are quite different, and they have quite different impact, not just on the application, but as well on what you look in the module. So today we want to focus there. and I want to give you the laydown what is different. With one exception, which would be winter gardens, all other applications have two characteristics in common. First, the balance of system cost, this means the installation cost, is very high or is higher than in normal systems. And the second is that they typically have higher bifaciality, higher gain because of bifacial. This is normally achieved because the hypos, the gain on height over the ground, and that increases the bifacial gain, or vertical, which is very bifacial, or separating the rows from each other, which is in fixed steel quite typical. Those 2 points, high installation cost and high bifaciality, are what move into choosing a different product or specifically fine-tuning what is the solar module that is best for agrivoltaics. Then we go into improving the two typical things: reduce the installation cost, increase the yield, but focusing on this bifaciality and how that efficiency or module power affect the installation cost. So if we look into that in detail, what are the technologies currently on the market? I'm going to focus on the current technologies, not PERC anymore. You have bifacial TOPCon, you have a back contact cell, currently only on TOPCon, and you have heterojunction. And you see that the highest efficiency is in back contact cells today. You see that the highest power is in heterojunction because back contact cell is not doing large cells. So there is a savings, kind of a balance in there, in the installation cost savings, and you have that the parameters for the best performance are clearly in favor of heterojunction that reaches a bifaciality of over 95%, which is not possible in the other technologies. That, taking into what it means for the application, means that if you want to save on installation cost, back contact cell is going to save you more than 1 cent in some occasions, maybe half a cent or a bit less. And in heterojunction, we save as well, not as much as with back contact cell because the efficiency is just a little bit below. And those are savings that are in the hand of people who install. And those are higher than if you just do normal photovoltaic where the installation cost is lower. So this is the first point. And the second point, which is for me maybe more important, is about the yield, because the bifaciality has such a big impact. This is based on simulations for France, which is a typical installation climate and location for us in Europe. And you get that the differences are massive. You can get almost 10% more yield when you use heterojunction compared to TOPCon, and much more than 10% compared to back contact cell in vertical systems. In the other systems, the differences are quite high as well. You may wonder, because this number, almost 10%, is so high, if that is realistic or this is just marketing bullshit. And it is not. Just go and do some simulations. Or even if you don't want to do the simulation, just think about it. If the front side gets the same yield, which it doesn't because you have other performance parameters like temperature coefficient, but just imagine it would be the same, then the rear side, which is half of the irradiant that goes to the module, will have a performance depending really on the bifaciality. So those numbers are real, so much so that when we have installation cases, real installation cases like we have in China and many in Germany with some of our partners, you see differences in yield over 10%. That is what we actually expect from the systems. Putting A and B together, you can see that for the specifics of agrivoltaics, you want to have a module that is both high efficiency and high yield. And this here, in terms of cents, is the distance in value that you need to get to the same LCOE. This means if you buy with a TOPCon system and you want to build that, you need to buy it, in this case, 5 cents cheaper, your TOPCon module, than heterojunction to get the same LCOE. Same applies to the other mounting system technologies. And that speaks a very clear language because those distance in cents are not in the market in terms of price. So as a summary, there are many reasons why you want to do agrivoltaics. Those reasons will change the topology of how you install, but in all of them, bifaciality and efficiency are super key, more than in normal photovoltaic plants. And for those, especially for vertical, heterojunction is bringing to the table a value that is just massively over what you have in the normal I'm going to say normal, in the other technologies for modules as of today. Thank you very much.
Well, Christian, yes, thank you for giving us that insight there into Huasun's approach to agrivoltaics. I wonder if you could just expand a little bit more for me. It looks like vertical orientation is essentially the focus there. So could you tell me a bit more about that generation profile in the context of the bifacial arrangement that you've got there, right? So
yeah.
I'm a farmer, I'm going to have two peaks, basically, during the day. I've got my morning peak, maybe I'm milking cows at the same time, I've got my evening peak. So what does that look like for a farm business? And yeah.
So this comes from the fact that heteroaction has always been known to be the most bifacial technology of all of them, even 10 years ago, 15 years ago. So everybody wanted to get that. And today in Germany, as we saw in the two very, very interesting sessions before this one, the time of day where you generate electricity is very important, and it has been already for a couple of years in the minds of those looking forward how to move generation to the morning and to the evening. So we are quite happy and quite lucky that we cooperate already for some time with some German very good engineering companies who have already a lot of Huasun on the field on vertical systems, who have a lot of experience application doing them. And we see that the value for the customer is so big there that that's why this is in my mind like the focus on it.
Okay, thank you, Christian. And just one more thing, I'm conscious we're lower on time, but obviously not every farm will be able to have a vertically orientated application. That's not going to be suitable for all agriculture. If I do have kind of overhead arrangements, you're talking about bifaciality and albedo. Is this an issue of spacing, right? So what's the kind of best orientation have you guys looked at for how I can maximize my value on spacing while at the same time, I'm not robbing the crops too much, right?
Yeah, this is quite an interesting conversation. I fear that we will not be able to go today into it, because for the high post agrivoltaics, mm-hmm. It is very depending on which crop it is, how much sun you actually want into it. Mm-hmm. We are preparing to go with a French partner into the market with a module with 33% transparency of the module itself, because we don't put all of the cells. And there are many solutions that just don't put, like in a window garden, everything covered with modules. But depending on the crop, you need to do it differently, because sometimes you cannot accept on the crop suddenly 2 hours of very intense sun and then shading, because that would damage the crop. So that is really more agricultural technology than electrical technology. And we support those customers as well, because heteroaction, let's not forget, has this very high efficiency. So all of those systems have lower installation cost.
Okay, thank you, Christian. Thank you for joining us today and for your contribution. Next up, we have our guest joining from the European Commission. Obviously, technical solutions are part of the puzzle for agrivoltaics deployment. Regulation continues to influence how, where, when PV projects go ahead on European farmland. And so to share an update on how the Commission is progressing with agrivoltaics work, we're joined by Policy Officer Ignacio Asenjo. Ignacio, welcome back to PV Magazine Roundtables.
Thanks a lot for having me again, Matthew.
Thank you. Now, last year, when you joined the agrivoltaics session, there was discussion of guidance coming from the Commission on agrivoltaics. We're obviously towards the end of 2024. Could you give us a bit of an indication on what's happened with that timeline and where that guidance might appear?
Well, as everybody knows, we are now starting a new mandate in the European Commission. Actually, it was only on Monday that really the new Commission took office physically, let's say. So we are now setting out the policies we want to address. Already in the last mandate, it was the intention to issue a guidance on what we call innovative forms of deployment, that we have also extended now to innovative technologies. A guidance means a document where the Commission tells the member states what they should do from regulatory perspective, also from financing perspective, to promote certain technologies or certain forms of deployment in this case. So for innovative forms of deployment, the reasoning goes that we need all forms of deployment possible for renewables, the traditional ones such as ground-based PV or rooftop PV, but also wind onshore and offshore. And we also need to think about other forms of deployment, taking advantage of the modularity of PV. And so we think about Agri-PV, but also we think about building integrated PV, infrastructure integrated PV, floating PV, etc. So the idea is to ensure that the regulations that we have at EU level and at national level really allow these forms of deployment to actually take place and prosper. And as any developers in these areas know, there are in all member states some regulations that create, let's say, complexities for the development of that. In the end, it was decided not to issue this guidance in the previous mandate, but will certainly be the case in this new commission. And I hope that in the next few months, in 2025, we will start really making progress in this file.
Okay, so 2025, there's a new mandate. We should start to see things coming through then. You obviously have done the study, you've completed the study. I'm not going to ask you in Roundtables Europe to read through the whole study. But what kind of regulatory barriers has the Commission identified? Can you tell us a little bit about the kind of things you've been seeing?
Yes, thanks for your question. In the study, I think the first thing we try to address is the issue of the definition. First of all, we think it's quite important at member state level to try to have a definition for any of these forms of deployment, but in particular for Agri-PV. And we have been looking at existing definitions in some member states, and in particular, Italy, France, and Germany have worked on definitions, sometimes with the support of research organizations like Fraunhofer in Germany. And we have noted that there are like 4 elements that seem to be quite common into this definition. Doesn't mean that we need to have an EU level definition or that we agree with those, but these are the elements that we have found common in the legal definitions in those member states, which is simply the fact that the 2 activities, electricity generation and agriculture, coexist on the same land, with agriculture being the primary use of the land, that the solar activity adapts to the needs of the agriculture to allow it to take place, that there are synergies between the 2, and that the adaptation, so the Agri-PV as such, is reversible and the land can come back to agricultural activity. And what we have seen in terms of regulations and obstacles are often related, in the case of Agri-PV, to land use regulations. It is quite important that land use regulations in the country allow for a dual use of the land, because otherwise, in order to have any kind of solar generation, you will have to switch towards industrial use of the land. And so it can no longer be an agricultural use. So it is important that the legislation understands that and allows that quite specifically. And in that sense, it is important to have a definition so that in these land use regulations and other regulations, you can refer to that definition to really understand what you are allowing and what are specifically the kind of activity you want to promote or to legally allow. So the definition is really the starting point, and then you start looking at other different regulations such as land use, environmental regulations, building permits, etc., so that you allow for this activity to take place.
Thank you, Ignacio. I can quite understand that dual use could be quite difficult, right, to pin down depending on the member state and the agriculture. Is that the kind of thing also then that feeds into CAP and how well agrivoltaics has been integrated with CAP? Is that still an issue? Is that still live, or have member states started to fall in line on this?
So these 2 things are actually quite correlated, because in the end, in CAP, so Common Agricultural Policy, you can you can enable everything you want, but if the actual legislation at national level does not really allow or facilitate Agri-PV, then it will not be reflected in actual CAP payments. So going specifically to the Common Agricultural Policy, it's important to understand that the current model for the Common Agricultural Policy is very decentralized, so the member states have a lot of leeway to decide on the payments, and they do their strategic plans. We are urging member states in their strategic plans to take into account the possibility to maintain Agri-PV and to support Agri-PV, meaning the possibility for farmers to maintain and continue to receive income support in an Agri-PV setting. But of course, that requires the member state to introduce that in the strategic plan and to define specific parameters to make that possible. One simple example is the case of Germany, which is one of the member states, not many, I'm afraid to say, that has introduced parameters in its strategic plan for the common agricultural policy. And that is a very specific 15% threshold, meaning that the land, so the loss of the land used for agriculture can be up to 15% in order to accommodate the solar generation and for the land to become an Agri-PV activity. And so accordingly, the income support can be reduced down to 85% of what was receiving initially or what could receive with a full use of the agricultural land. So they have thought in Germany specifically about how to allow this compatibility and this use of Agri-PV, so of the agricultural land for solar generation, while maintaining income support. This needs to be done in the different member states, but it's only possible if the general regulations in the member state actually allow for Agri-PV to take place.
Thank you, Ignacio. That certainly brings us up to speed there. Thanks for joining us today, and we look forward to seeing what the Commission comes up with in 2025. As you can hear, we could talk about that issue perhaps all day, but now we're going to be joined across in a panel discussion with some more key experts on this issue of regulation. So, to dig into agrivoltaics key issues in key European markets, we are joined by a panel of 4 leading experts. Oltis Dallto is Agri-PV manager at Juwi Group, a developer with a 300 megawatt agrivoltaics pipeline in Italy alone. Heinssen is CEO of German legal practice Kanzlei and Lühe. Constantin Klyk is the founder and consultant at Agri-PV Consulting, and Emilien Simonot is head of agrivoltaics at Lightsource BP, a leading developer in the field with a global reach. Now, Oltis, thank you for joining. I'll come to you first. At the start of this year, you and I had a discussion about updates to agrivoltaics legislation or regulations in Italy. Then in May, there was some talk of a ban for ground-mounted PV, and my PV magazine colleagues at the start of this week were reporting on an agrivoltaics tender. So I'm hoping you can maybe explain to us what's going on with regulation in Italy, and what does this mean for PV deployment in general?
Yeah, thank you, Matthew, for the invitation. In order to give you the impact of the Italian PNR Agri-PV funds decree in Italy, just give me 30 seconds to give an overview in European level. According to the Agri-Solar Digital Map from Solar Power Europe, actually there are more than 2 gigawatt active projects in Europe, nearly 90 projects, and regarding the size, 85% of that is more than 20 mega, and only with 4 projects greater than 100 mega, they achieve 850 megawatt. And regarding countries, Spain is the leader, holding nearly 1 gigawatt of with only 2 projects of Agri-PV projects. And regarding technology, 91% of that it's ground-mounted PV or inter-row PV systems. 61% of that is livestock regarding the applications, with half of the project, and 50% of that is crops between the lines. 3/4 of the total capacity of ongoing Agri-PV projects in Europe are regarding solar grazing. But what will be the impact of the Italian PNR projects? The PNR, the National Plan for Recovery and Resilience in Italy have 6 missions. The second one has green revolution and ecological transition. The first component is specific for increasing renewables, and the first investment of that regards Agri-PV. So in December there was this Agri-PV decree approval, and the Italian government was aiming for 1,040 megawatts. 30% of that was a smaller project, less than 1 mega, and the farmer is the only investor, and this project got direct access to the incentives, and 74% of that is project greater than 1 mega, when energy companies with a farmer related by a contract, a specific contract, can apply for incentives. So there were some requests. The request deadline was in September. They arrived nearly 1.76 gigawatts of requests, nearly 645 projects, but only 540 projects survived. We have the definite numbers this Monday, and it's split 50-50 between the smaller project and the bigger projects. And let's say there will be 1,370 megawatts of big scale, utility scale Agri-PV projects that are obliged to use high elevated structures. So there will be, let's say, a game changer also in a technology perspective. The Italian Agri-PV projects will for sure change the way how Agri-PV projects are being constructed, actually. And there are two main documents, the operational rules. I won't go into details. And there is, let's say, the monitoring of the continuity of the agricultural activities, which is the main and the most important and the most difficult parameter to achieve, that explain how to perform, let's say, the continuity of the agricultural activity.
Thanks, Oltis. I mean, it sounds to me certainly like regulation is playing a significant role there in shaping the market, right? So we've had PV development in Italy in this kind of traditional fashion, and now regulation is stepping in and it's routing the direction of the kind of projects we're seeing in the future. Would that be accurate to say?
Yes, for sure. I mean, this May, you said that there was this blocking of PV ground mounted in the agricultural area. So there is this fear of losing agricultural area by applying PV systems on this. So let's say from now on in agricultural area in Italy, only high elevated systems will be approved and will be allowed.
We'll come back to Italy, I'm sure, but also I would like Angela to bring you in at this stage, because Germany is another one of those European markets, and Ignacio mentioned it earlier, I believe, with some fairly developed regulations on agrivoltaics. Now, you were one of the people who contributed to the latest update this year on agrivoltaic regulation in Germany. Could you give us a bit of an idea what has been introduced in 2024 in terms of animal husbandry and what it might mean for German farmers?
Yeah, thank you so much for having me in the panel. And thank you, Ignacio, for acknowledging that Germany is doing so much on the regulations. We have the famous regulation DIN spec, which is a standard DIN spec 91434, and we have the regulations on the cap that we say it's still the subsidies can be paid. But in 2024, we have two very important new regulations. This is one regulations on the small farm for the small farmers. So they do have a special privilege if they just build Agri-PV on 2.5 hectares. It has to be in a spatial and functional relationship. It has to be close by, although it's not clear defined how close by it has to be to the farm. And there has to be a farmer, and it has to kind of be assured that there is a successor of the farm. But key is what is Agri-PV, even for the 2.5 privilege in the building law. So I had the privilege myself of being in the consortium for the new DIN spec. It's called the new DIN spec 91492 for Agri-PV with animal husbandry. And we were sitting on in the consortium for over 1 year to find a clear and good definition, which is including kind of regulations on the stocking density, which is it has to be 85% of the stocking the stocking density in the area before. There has to be, this is new, there can be a flexibility of the land use, so you can change the land from arable land to grazing land. It's very much discussed, but it's in the regulation. There are some definitions of the clearance height, which is 2.1 meter, as it was before in the DIN spec 91434, but there is a new clearance height for poultry, which is an exemption, and we talked about that a lot, but it has to be close to stables in order to function for the poultry. And there are some animal welfare requirements in it. So the light has to distribute so it maintains natural animal behavior, and they have to have access to drinking water, and we have to make sure that the soil erosion is not too strong, so there is a stable ground. But let me say that we discussed the most discussion, and this is why I'm so happy to be invited here, was this Agri-PV with sheep is Agri-PV or not. I know that Oltis and many are following him says, well, in Sardinia we do have so many sheep, and it's traditional that we have that we are grazing sheep here. So Agri-PV should be with grazing sheep. When we were in this consortium, many people were saying there is no Agri-PV with sheep because they are just mowing in the traditional ground-mounted PV, and you can never consider them as Agri-PV if there is a PV with sheep. But still in the new regulation, there are sheep included. And I think we will have to discuss that matter. Do we want to include sheep, and how do we define Agri-PV with sheep if we agree on having Agri-PV with sheep? And what are the details? When I posted it on LinkedIn, I had a really interesting comment on this, and they say you cannot just have a stocking rate of 85%. You have to get into more detail, because then you have to take, say it's the ewes that you have to count and not the lambs and the rams. And you have to see that sometimes you have to leave the land alone and you're having them in the paddock. So these are details of a definition, I think, that will be looked in 25, in my opinion. It's really important. Yeah. And similar discussions we will have on Agri-PV with poultry.
Yes, absolutely, Angela. Thank you. I'm going to put a pin on counting sheep at the moment, but I'm sure we will come back to that issue shortly. But I would actually at this point like to bring in Constantin Klyk as well, because we've just discussed the kind of incentives that can be there for small farmers in Germany, but the reality on the ground is that we're not quite there yet, right? We're still waiting on some guidance. We're still waiting to see how things are going to progress, and if we can actually get that kind of feed-in situation there for installations on German farms, smaller farms at least. Is that correct?
Yes, exactly. So this is also actually one update that had happened this year in Germany with Solar Paket 1, and there is a special feed-in tariff for Agri-PV, so a special auction, special feed-in tariff for small projects, but also for bigger projects. Now the situation is, let's say, a little bit difficult at the moment in Germany. There's many companies, many farmers, just a lot of stakeholders waiting for these additional payment, or they are not waiting. They're waiting for the EU approval. We still don't have EU approval for these additional compensations. And this is going for more than half a year now. What I feel in the whole area of Agri-PV in Germany, that the stakeholders are slowly losing trust that it's going to come. So in the beginning, for what I felt, it was basically, okay, German government made this decision with Solar Paket 1, and the acceptance from the EU Commission is basically already, we are just waiting for it. And since now half a year later, nothing has happened. 2 auctions that should have happened in the beginning of July, and now in the beginning of December, they both didn't happen. I know of many farmers who planned with small projects on the 2.5 hectares, smaller than 1 megawatt, expecting to get 9.5 cents for their power. And these projects basically don't work without this. Such a small project is really hard to make it work with the current situation on what money you get for your power. So this is really difficult, and yeah, we are all basically here waiting to get a decision. And even if it's a decision that it won't come, it is good to get clarity, to not put more money into planning these projects, and just give the possibility to make decisions.
Yeah, absolutely. And that buy-in from communities and from the farming community in particular is so important, right? That's the idea. If we're going to achieve deployment goals, we need the community to come on board. But I'd like to move on, not to a small farmer, but a rather big developer. Emilien, I think this is the perfect time to bring you into the conversation now. We've just heard about technical regulations in Italy and technical regulations in Germany, and there are technical regulations in France, and we're calling for more regulations in other markets. Isn't the key to solar deployment that this is modular and straightforward? And what does having all of these kind of different standards and technical requirements appearing do for you as a developer if you want to make the business case for agrivoltaics?
Thank you, Matthew. Pleasure to share the panel with my colleagues around. It was nice to hear you. So first, I think just to introduce on the topic, I think you're exactly right. You mentioned we've seen today Italy. We've also been discussing Germany, France. You mentioned that, but the ball is growing. If we look at Europe, we know that many other countries, they have started the process of regulating Agri-PV, either by committing a potential report at country level, either by already starting some innovative funding for demonstration projects like Spain very recently. So beyond the countries that are, let's say, more on the edge of advancing the Agri-PV regulation, there is a mass of countries that is following. So the ball is growing, and this is something that we have to consider as a main segment of the PV market in the future. When it comes to the complexity implied in the regulation, of course, we've been discussing today the national level, and we've been getting a few examples of what advanced Agri-PV regulation looks like. But I think it's also important to understand that in many countries, those national regulations, they also have developments are at more local level. For instance, in countries like Germany or the Netherlands, municipalities have quite a lot of power in terms of framing a project, a PV project, into an Agri-PV project, or even providing some recommendation on Agri-PV projects. In France, it's a committee that is at provincial level that is actually ruling on whether the project fits with the Agri-PV regulation or not. And then we also see a number of entities. It could be label entities managing agricultural labels. It could be association of farmers that develop more and more guidance on how to do Agri-PV projects for such type of culture or for such type of agriculture activity, which obviously are not mandatory, but then when you have to present your project and get the approval from different entities, authorities, chambers of agriculture, you are always with a question in mind, shall I go and apply those guidelines, or do I have a bit of freedom? I mean, it's a bit of a gray area, okay? So on the one sense, all those measures and how they land at such a granular level is good because, I mean, I think it's been highlighted. Agri-PV has to adapt to the territory, has to adapt to the agriculture, and that is something that we understand as a developer. But on the other side, it poses the question on the modularity and how we can make the most of this big PV force, being modular, being low cost, being replicable, and how do we adapt that to Agri-PV? So that's one question on adaptation of equipments. and when I say equipments, I'm referring to the whole project cycle. So how do we permit a project? How do we design? How do we choose our equipment to make sure we provide the synergy that Ignacio was mentioning with the farming industry? And that's where we have a first area of extra cost because of this adaptation. The other one, and this is something that was highlighted very nicely in the last Agri-PV conference in Madrid a month ago, which is the cost of capital. We had a very good intervention there of a technical advisor that was saying money is shy, money is lazy, and money is compliant. So if you increase the number of requirements for a project, you increase the level of risks. So you also increase the cost of finance because you will have to provide extra guarantees. Okay. So how do governments make sure that still project can happen? It's about carrot and stick strategy. Stick is let's ban regular PV on agricultural land and let's do Agri-PV. And then the carrot is let's provide tariffs, let's provide grants for funding projects. But at the end, I make a bit the link to Angela's comment on sheep grazing. What we are looking here is a replicable solution to address climate change, to spread new opportunities in the farming sector. So we also have to go towards things that are widely replicable, widely that we can build in a very quick way and that are also economically sustainable. No? Because at the end, grants, tariffs, that's taxpayer or energy bill payers' money that goes into the projects and that ends up into farming. And the bans is also means that all the projects goes Agri-PV. So we also have this kind of lack of competitiveness on the power sector at national level.
That last point that you make there, I mean that's the critical one, right? I mean, we're talking about regulation, and a lot of it is in this context of what kind of feed-in tariffs can we do, what kind of subsidization can we do, how can the government intervene in the market for agrivoltaics deployment. But can this, do you think, Emilien, can this pay for itself without us needing to over-regulate and decide exactly what happens at the local level, whether it's in this Southwest France has this particular rule, Northeast France has this particular rule. Is there a future for agrivoltaics that isn't dependent on us finding a framework on which we can subsidize it, essentially?
Yes, I completely believe there is. The first reason I believe there is because all those fundings, I mean, we have had experience with the beginning of the PV sector 10, 15 years ago with the feed-in tariffs that have gone out of the market. I mean, the PV sector has gone full merchant at some point and competitive. No, so this will happen for Agri-PV. Either if there is, they say those tariffs shrink down because the countries are not able to maintain them on the long term, and also by the adaptation of the techniques. No, if we understand that elevated structure, more advanced Agri-PV systems are more expensive. They are delivering a very high level of synergies, but at the end, the economic sustainability will also have to put that in the balance. No, we are still able to deliver very good level of synergies with completely off-the-shelf bankable equipments that the PV industry has been using for the last 10, 15 years. A one-axis tracker is very good at light sharing, is very good at improving evapotranspiration on the site and at delivering synergies for Agri-PV.
Yeah, thank you for that, Emilien. But Constantin, I would also like to bring you in here. You're a consultant, you work with different people. Does that chime with what you encounter in the market? Are agrivoltaics bankable even in the current regulatory situation, or do we need to wait on that easy European Commission guidance to come in before this thing can really get a rocket under it and start deploying at scale?
Well, it depends on a lot of factors. It depends on a lot of factors, like also a PV system depends on a lot of factors. But for sure, there are solutions that are bankable, definitely. What I spoke about were really small projects that have trouble, but also a really small PV project has trouble to get a good IRR in the times where it's really where we get really low cost electricity out of PV. So yes, as I said, if the size increases, if we find the right ways to market our energy, then definitely they are bankable. What I was criticizing is really the unsecurity. At the moment, we don't know what is going to happen, and unsecurity is always a problem.
Absolutely. And I'm going to take your point on insecurity. And actually, Oltis, I would like to bring you back in because we've talked so far about regulations in the context of the engineering of it, of the possibility to subsidize. But this is farming, and we rely on topsoil, we rely on biodiversity. Are the regulations doing that job? Do you think that there's more that we need to do on this end also, and maybe take a bit more of a look at what's actually happening in the soil?
Well, actually, this is a very good question. In order to answer that, I have first to explain that in 2022, the ministry released a guideline for agrivoltaics in Italy, and it contains a list of additional parameters for Agri-PV projects in order to be eligible for the PNRR funds. And we did, as Juwi, we did a comparison between the guidelines and what are the requirements of the PNRR decree. And actually, there are some gaps. I'm talking about, we have the results now, only 1.9% of bigger projects, greater than 1 megawatt, will use the energy produced for self-consumption of the agriculture, which is, let's say, contrary what was the mission of the PNRR goal. And we have some gaps also on the soil fertility recovery, since there is no absolute indication on how to measure, on how to evaluate it. And there are, let's say, some other gaps containing, or let's say, no good information how to increase the environmental performance of these projects. I'm meaning the biodiversity, ecological service, and also landscape integration or mitigation. So since this PNRR decree will apply to all future Agri-PV projects in Italy, these gaps should somehow be filled.
Okay, well, that definitely feels like an area that we have to go and do some more work on for sure, and looking at biodiversity. Very short on time, Angela. Just if you could, you are, I believe, the only person in the panel from a farming background. Despite all the regulatory difficulties, do you see this as an opportunity for those kind of farming families throughout Europe?
Oh, yes, definitely. And I can report from the two events I was this week and last week, and I saw that there was from the Farmers Association, and just yesterday was the orchard farmers nearby. And you could see that there were like over 100 of farmers at each conference. And although the Farmers Association said it's really difficult to build them and you cannot be sure if there are feed-in tariffs and it's not clear what the definition is, you still could feel in the room that they all wanted to invest because they want to earn. They have a separate income, a second income, and they want to have a modern and smart farm. So they have three elements. They have the income from the agriculture, the income from the energy, and then they have the benefits of the digitalization, because you have to see the new generation wants to invest and wants to see if they are the successors. And they will do that with Agri-PV in scaling up in small Agri-PV projects and not just one large Agri-PV or ground-mounted PV project, but many, many small projects. And I feel the farmers really are there to start, and they need the money, the funding, and they need the clarity on the bankability with the feed-in tariffs. And I think it's a wonderful story, not only in Germany, but worldwide, in India and Africa, that we can see developing.
Thank you, Angela, and thank you to all four of our panelists for joining us today. Now, it's clear from the discussion that there's far much more we could go into on this issue, but we won't quite have the time to discuss further on those regulations. There is more, of course, to come. We are going to very shortly be joined by our guest from Huawei to talk about how inverters fit into this whole situation as well. And now we will shortly be joined by a guest from Huawei. I believe we're just working in the background to bring that together. It's probably worth then at this stage doing a bit of a recap on the session as it's come so far. Or alternatively, our man is back. So let's go straight to it. Are you with us?
Yes.
Hi, Guluma. Thank you. Sorry, I think we just had a little technical issue there. Welcome,
Yes.
and thank you for joining us. Rather than waste any more time on me filling in time there, will we jump straight in? You've got a presentation for us about inverters and how they fit into the scheme of things with agrivoltaics.
Great. Thanks for having me. As I indeed had a short technical issue with my network, but I'm online now. I don't know if my slides are already up. Okay, there you go. I have a short presentation where I start, first of all, with a short introduction of Huawei Fusion Solar, because I think Huawei is known, but not Fusion Solar. Then talk about drivers and classifications, even though I don't think I need to do it in detail in this case, because it has been discussed. Then focus on the requirements for PV inverter selection and our Huawei solution. And last but not least, give some examples from Germany, some project examples in Agri-PV. Short introduction of Huawei. Huawei, I guess, as I said, is maybe well known. I just want to highlight where the Fusion Solar brand is located too. Huawei has different field of activities and business units, and myself and my colleagues are working in the digital power business unit, which is on the right-hand side, which is again divided in 4 different fields of activities: smart PV and ESS. Smart charging network, drive one data center facility, and Fusion Solar is specifically the business unit which is focusing on smart PV and energy storage. So in order to really make sure that everyone knows what we are doing, we have defined the Fusion Solar brand to identify us within the Huawei group. Talking about drivers, I guess, has been discussed already quite in detail. I just want to mention that land shortage is the main driver for Agri-PV, and it is in conflict with the expansion targets in Europe. On the right-hand side, since I'm working for the German rep office, I have a specific example, what you may see on the table, where you see the land usage in 2021, the daily land usage, which is 54 hectare per day, already in 2021, and the target is to reduce the land use, daily land use to 30, which obviously is in direct conflict with the expansion plans in Germany, where Germany wants to achieve 215 gigawatts of solar PV by 2030. So this is only possible by utilizing of areas like carports, but also Agri-PV. So we think there's a major driver for the Agri-PV business. On the next, I would like to highlight the different Agri-PV scenarios. I guess I don't need to repeat that. I just want to highlight it in the manner that there is a difference between a ground mount and the elevated plants. And the definition from the Fraunhofer Institute is, from my point of view, quite detailed, and also gives a good overview for those who maybe are starting to investigate the options of Agri-PV. Since the focus is on the inverter side, I would like now to jump to the inverter and then talk more about the inverter requirements. Since we are deploying Agri-PV in a harsh environment in terms of, let's say, impact on the inverters, either with dust, muddy conditions, even wet conditions, I guess, or because of these, robustness is a very important feature of inverters. Beside the robustness, we believe the noise level generated from the inverter during the operation time is also critical, because Agri-PV plants are collocated close to, on one hand, to settlements. On the other hand, also the welfare of the animals needs to be paid attention to, because they are very close to the plants. Inverter power class, that's a feature or a requirement which is affiliated to the fact that Agri-PV plants are using those who are elevated are using semi-transparent PV modules, which also have some space constraints. Based on that, shorter rows will be only possible, and because of that, smaller inverters with multiple MPPT inputs are preferred, and the multiple MPPT inputs also one of the criteria for the flexible plant layout, which is the last point as a feature, because in order to achieve the highest yield, you need to make sure that each row is connected to an MPPT, and this is only possible if you are utilizing inverters with multiple MPPT inputs. Last but not least, the safety, I guess, because one is plant safety, but on the other hand, also since we have animals which are unpredictable risk factors, are requiring also some safety measurements, and also the fact that we are working in hot, dry, and wet conditions. As a next, I would like to give an overview of the Huawei portfolio for the Agri-PV business. On one hand, we have the 400-volt solutions coming from the commercial industrial platform, which has a wide range of products starting from optimizers up to battery storage. The same applies for the utility portfolio with 800-volt output, which means it is always used to be connected to the medium voltage or higher, and therefore you have, it's rather applicable for larger Agri-PV solutions, which or applications which are also happening. But I guess the first, specifically talking about the German market, which already been addressed, there's a constraint of 2.5 hectares per plant, and there we are only utilizing smaller PV plants, and because of that, we believe the C&I inverters, respectively the 400-volt inverters, and the one which is marked red here, which is a new product, is a good fit to the requirements, and therefore I would like to highlight some of the features of this product, which is classified in two platforms. One as a standard string inverter, as a SUN 2000 series, which is not able to work with optimizers, and the second one is the SUN 5000 generation, which can only work with optimizers. And I believe, from my personal point of view, I believe the SUN 2000 is a good fit for such Agri-PV plants, because it is has the best of both worlds, since it can be used for rooftop as well as small ground-mounted project, as is the case for the Agri-PV. But in case there's a rapid shutdown requirement, either from the customer or from the insurance, the SUN 5000 can also be deployed, which is usable in combination with optimizers, which allow the rapid shutdown function. Some highlights here again, and here I would like to, I don't want to bore with the details of the specs, but important to highlight are the DC input parameters, which are marked red. As you can see, the SUN 2000 has 21 DC inputs, which gives a maximum flexibility towards the string and the plant layout, high input current as well, and a high voltage range for MPPT tracking. And based on that, I believe is a good fit for the Agri-PV business. On the right-hand side is the SUN 5000, which only have 12 inputs, but it's only 12 because it can be used with optimizers, which allow longer strings, which means you can reduce balance of system cost by using longer strings, and based on that, 12 strings inputs are sufficient in order to achieve the 150 kilowatt output. That said, I hope I was able to give an overview about the Huawei portfolio and also highlight a suitable product for small Agri-PV plants. And I would like to give some examples of projects. On the left-hand side, we have, let's say, ground mount site, which where you can see the inverter on the top, which is connected below the PV panels. Also another one on the right, on the bottom left, where you see also the inverter located below the panels. On the right-hand side, we have currently the first hop cultivation site As you know, Germany is a beer country, and based on that, hop cultivation is very important. And this is the first project which is deploying the Agri-PV scenario. So based on that, I would like to thank for your attention. And if there's any question, I'm happy to answer these questions.
Thank you very much, Guluma. We are quite tight on time now. If I could just ask you very, very briefly. First of all, you touched on it there. Integration of storage as well, co-locating storage. You see that as a valid way of going about an agrivoltaics installation, and this works together with Huawei, yes?
Yes, that's possible with our solution, and the issue is that in Germany we are facing negative electricity prices during the day, so we believe despite higher feed-in tariff for Agri-PV plants, there will be a business case for battery storage in order to have higher revenues for Agri-PV plants, because the higher feed-in tariff is already very attractive, but it can be increased by utilizing the energy storage to shift the generation or the feed-in towards higher peak prices, higher electricity prices at the power grid.
Excellent. Thank you very much for that, Guluma. I must say we could start a whole new conversation on co-locating storage with agrivoltaics, but we just don't have the time at the end of the hour. So thank you again for joining us. And in fact, thanks to all our speakers who have joined today to discuss a segment of the solar industry that I'm sure you can see continues to pose serious questions but has significant potential. Now, in this session, we've heard from leading module and inverter manufacturers on the technical challenges of agrivoltaics and how they're attempting to solve them. We've had an update on how the European Commission is progressing with its efforts on agrivoltaics, and we've heard from some of Europe's leading experts on what this all means for PV developers, and perhaps most importantly, the farming businesses that will be affected. How far agrivoltaics deployment will go remains to be seen. But it's clear there is plenty of interest in integrating energy generation in agriculture. There are lots of challenges to overcome, but there's also plenty of news on the horizon. As we heard from our guest from the European Commission, Ignacio, we should expect to see some guidance in 2025 for member states on agrivoltaics and the way that this can be integrated into their regulations. And we also expect to see from Huasun some new developments in the first quarter in France, perhaps around semi-transparent modules. And lastly, from Huawei there, we have heard all about how they are integrating inverters and this kind of new frontier, I guess, for a business that is well known throughout the world, but is breaking into a segment in agrivoltaics, which, has whole new sets of opportunities as well as challenges. Now, before we go, we will be joined later on today with some new kind of pioneering work, which my colleague Frederica will be joining to tell you all about. We've got a whole host of exciting startups who are going to join to show exactly the way that they are trying to carve a new path in the photovoltaic and storage sectors that we have been paying so much attention to throughout the course of today. So once more, thank you for joining on Agrivoltaics. I'm Matthew Lynas, one of the editors here at PV Magazine, and please stick around for the next session.
But back to the session that is coming up. Tristan Rayner will be joined by our news director Emiliano Bellini and Matthias Engel from Virio Ventures. But get ready, dear audience, or dear viewer, because we will ask you to get involved. During the session, you will be able to vote for the startup of your choice, the one that you find the most innovative. So listen well and do stick around for that right after this.